Hi there. Am I audible?
Yes.
Yeah. Yes.
Yep.
Awesome. Thank you.
Okay, good.
I think we're recording, so we can begin.
All right. Well, it's good to have everyone here. Meta's all primed and ready.
That's what I do.
It's funny because I wanted to open this one a little differently, just for a second, if you don't mind. Bear with me. I think a lot of people have heard me talk about in advance of the membership meeting. I know that a lot of people have heard me talk about how one of the visions for RChain is to reboot the coordination technologies, and that there's a reason why, there's an urgent reason why those coordination technologies need to be rebooted. I'm sure that for many this might seem far in the distant future or not relevant now. But if people are following what's coming out of the Senior Science Advisory Body of the UN, they've recently released a report that gives us just over a decade to coordinate to radically, I mean radically, change our consumption patterns, our supply chain management, and in general the way we conduct ourselves, or face the catastrophic consequences of a 1.5 degrees Celsius rise in temperature, which will change arable land, farmable land, which will change coastlines and a number of other things, which will have really dramatic impact on our existing infrastructure and on our lives and on our wallets. And so I just want, the reason I'm pointing this out is because it's no longer off in the distant future. We're not talking about a few crazy scientists. We're talking a very significant portion of the community, the scientific community, and the regulators and policymakers who are now very, very much aware of the reality of this coming. And I want to use this as a driver and help people understand why I have such an enormous sense of urgency. We need a network like RChain because we need to be able to coordinate with ourselves in the event of very, very dramatic changes to our existing infrastructure. And so this is why I hope everyone is pulling together to make sure that we can get this network built. So on that lighthearted note, let me turn it over to you, Meta.
Thank you. Give me one moment here, just a second.
Just real quick while waiting for Meta, RChain Europe has their own channel now. So Greg, thanks for showing up in the morning. It was just, they just conducted it in their own room. So if anyone's wondering where those updates will be, they'll just be on the RChain Europe YouTube. I'll go ahead and post that link in the members channel.
All right, one sec. Here we go. All right, can you see my screen?
Yes.
Great.
Yes.
Yes.
All right. Thank you, everyone. So here to present the community update, the development update to the community. We've got a lot to go through today. I've got some demos. My big focus, as a lot of you have participated in, is getting Node 7 released this week. We're close to be release ready. I've also been working on the RChain improvement process, the RIP process. It's in draft mode, calling for community members to go ahead and take a look at that. Anyone that has expertise or an interest in how we get updates onto the software platform, please do weigh in on this. Into the development updates. Initial threading fix is in place thanks to the node team. RSong reported significant improvements in retrieving data from the chain, about a 6x improvement. That would mean that getting data off the chain was 6 times faster as a result of just the initial threading fix, which is very, very nice improvement. Node 7 releases this week. We do have a blocking bug, roll 917, that we will be focused on identifying and fixing this week. We hit this bug twice during node testing Tuesday, and it's critical enough that I want to hold updating the testnet until I know I've got a fix in there that's confirmed. And I've indicated that we need the bug fix before we relaunch testnet. I will be demoing the features of Node 7 this morning. And Mike Stay will be also demoing the registry. So we've got cost accounting that we're going to demo. We've got validator bonding that we're going to demo. We've got the name registry that we're going to demo. And then changes to show block and show blocks. Cost accounting, we got a PR merge this morning. There is a change to the Rolang language. Logical connectives are now restricted in the patterns of receive and logical and only. Please do take a look at that PR and feel free to have a discussion in the development channel on the public RChain Discord. The name registry is that has been merged. You can now register with public names. There is one issue that we're looking at. There's a security flaw in the registry. Mike Stay and Kyle are looking.
No, it's not a security flaw in the registry. It's a security flaw in the existing code that has been written because we didn't have a registry. It just used that idiom, and we're just changing the idiom.
Okay, got it. Thank you for that clarification, Mike. I'll update my status report here. There is a PR to remove listening and sending unforgeable names. We're holding this PR until all the contracts are ported. There's a Rolang cheat sheet to be delivered this week by the developer site. Thank you to Joshi and Derek to create this resource for Rolang developers. On the Casper side, we have a testnet faucet that supports validator bonding. So those of you that participated in the bonding tests, you knew that last week we had to use a wallets file, and we had to go through a few extra steps to bond. You still have to generate the bonding files, but there is an API within the node that supports that. The documentation is in the -- help and in the GitHub README, which makes validator bonding that much easier. And the bond amount comes from a faucet. We ran a test, and we got that PR in there that's going to help improve error messaging and logging to help diagnose the issue. And my goal is to try to host another community test tomorrow morning. So if you're interested in helping me diagnose this issue, 7 a.m., same channel, we're going to try to use a version of the node that has deeper debugging and try to repro the issue so we can get some diagnostic information to Kent. Validation of the Genesis block is taking too long. We would like for the validation of the Genesis block to take about 20 minutes. Right now it's taken about an hour and a half. And this is going to be investigated by the RSpace team in the future sprint. We've logged a ticket for that. The block store is an implementation. So I expect the PR for the latest messages store to come in tomorrow. So that's moving along very quickly. That will also improve performance of both Casper and stability. I mean, this is really about restoring the state when there's a problem with the node. And as you all are aware, you have to delete the rnode directory and start from scratch. So it's really an important feature that we need in the platform before Mercury. The node team, Casper's been moved to a streaming API. They're writing integration tests. And this is to support unlimited block sizes. Everyone, please mute. As part of that work, we need to address how drop messages are identified and handled. And there's a meeting scheduled later this week to discuss that. The storage team is focusing on performance. One of the key areas of performance is how we serialize and deserialize continuations. And we're looking at benchmarking the S codec against Cryo. Cryo touts that you don't need to deserialize a binary in order to update it. So if we can save that effort, that would be fantastic and a very nice performance improvement. So we're going to benchmark that before we move forward. We're also looking at investigating storing continuation patterns separately for faster access. We're also investigating why replay is less efficient than proposed. And again, this is all inside the tuple space. This is all storage work. SRE team, we're fully ready to shift drone CI, shift to drone CI in Java 10 following the release of Node 7. We currently have both running. Correct me if I'm wrong, Kelly, but they're running side by side until we wait to cut over. And we're also looking at integration, improving the integration test suite. The goal being it should be very easy to author new tests and extend the integration suite. And we're working on figuring out a way to implement a process to obtain server logs from nodes. So this came out of testnet, right? So if a testnet node has a problem, they should be able to send us their logs so we can file a ticket and basically debug the information, debug the problem. We're continuing to work on the incentivized testnet. Look for more information in October and the start of challenges around December. We will be updating developer.rchain.coop with release information about Node 7. I see lots of messages in the chats. Any questions about my update?
It's mostly me.
Okay, great. All right, so the first thing I'll show, I'm going to demo real quickly for you here. First thing I'd like to demo is, as you're all aware, as part of Node 7, one of the items that we've got is we have now cost accounting. And so as part of Node 7, the first piece is to really start aggregating and collecting up the cost to execute Rolang. And you can experience this if you download the RNode software and you run the eval function, which basically just says evaluate this Rolang file. It doesn't send anything to the blockchain, but it runs the Rolang code in the Rolang interpreter, which is part of the node. So I'm going to evaluate a very simple file here, hello.row. I'm sending this against my current node, the node that I'm running here locally. And you'll see here a cost account. This is a deployment cost. And this is the result of the cost accounting work here. You'll also see we've got some nice pretty printing here. It shows how the code was evaluated, and it shows the inforgeable names that it generated as a result of this evaluation. What are the steps? I mean, what are we looking at here when you look at cost account? 18, I believe, is the number of reductions, the number of reduction steps. And then 404 is your cost in phlogiston. So very nice feature here. In future iterations, we're going to see taking this phlogiston, putting it in the proof of stake contract, and then dispersing those fees to validators. That's expected in Node 8. And then eventually, in conjunction with that, we'll start requiring phlogiston for execution and having a proper deployment process where you have to fund deployments. And that will align with having a wallet that will dispense revs so that people can actually test contract execution and the full deployment lifecycle, right? The full workflow with respect to deploying Rolang contracts to the blockchain. So that's the cost accounting feature there.
Hey, Meta, it looks really great. That cost, is that transaction cost and storage cost?
Yes, we don't have a separate notion of storage. Mike, keep me honest here, but I believe that includes the cost to store the contract on chain. And I think it's just a lifetime, correct?
Yeah, so we have a proposal for a storage shard, which will, it runs code just like a normal shard, but has a thing in front of it that restricts which contracts it's willing to accept. And the specific menu of contracts will be tailored to whatever you're trying to store. So for example, if you're storing audio files, the contracts will probably include proportions of fees paid to the contributors to the creation of that file. But there will be a fixed menu, so it won't do generic processing. It will instead be tailored to storage. And on those sorts of shards, the majority of the fees will be for storing. They'll also have parameters that allow specifying rent as opposed to permanent storage. So the fees shown there on the command line are indicative of how much it will cost to store something. but the exchange rate will depend on what shard you're doing it in.
Okay, cool. Thank you. That's really exciting. I mean, the whole storage thing. Thank you.
Here I'm demonstrating on my screen here, if you take a look, this is what the new, the deploy parameters look like, right? So the -F is basically the address. It's a placeholder right now. It would reference a wallet address. The flow limit is the maximum amount of phlogiston I'm willing to pay for this execution. And the price is the exchange rate. Right, so we just stub in the value of 1 for the time being. So I have this amount of phlogiston to execute hello.row. As we know here, the cost of execution is 404. So I've done more than enough to fund the execution of hello.row on the blockchain. If that makes sense. Any excess flow, we specify this as a flow limit as the maximum amount that I'm willing to pay. Now, if you don't specify enough phlogiston, guess what happens? Nothing. Right? The deploy goes through, but nothing gets added to the block. And I've seen this. I know this works because it tripped me up a few times. Moving along, I'd like to demonstrate show blocks really quickly. So we have changed the behavior of show blocks. I have a few blocks on my node at the moment. I've already set that up. So here you'll see that when I say show blocks, it by default is going to bring back the latest block. As you'll see here, it says block number 2. If I want to show all of the blocks, I specify parameter depth and a number in terms of how deep I want to go into the blockchain, and then it will return back for me all of the blocks, because I know that I have 3 blocks. I've got the Genesis block, which is block 0, block 1, and block 2. You'll also note here that the tuple space hash is not part of the blocks anymore. So when you do show blocks, you just get the header information. If you wish to see a particular block, you have to execute show block and the hash of the block. So if I want to do bin or node show block, and then I select just the leading few characters of the hash of the block. This will take a minute, but here you can see it returns back the full tuple space. Any questions so far on this? Okay, great. I'm going to attempt here to share a video. I don't know how well this is going to work, but we're going to try it. This is a little blurry, so I apologize. What I'm attempting to show here is validator bonding. I don't know if the audio is coming through. Probably not.
It's not.
Okay.
Is this a recording from yesterday?
This is the recording from yesterday. So what I wanted to show here, it's really fuzzy. Oh, that's unfortunate. What I want to show here is we were able to demonstrate validator bonding. So if you go through the bonding process here, what I'm highlighting right now on the screen is the public key. So here you see transfer out. This is the action of the bond amount being transferred out from the faucet. And here at the bottom, what I've currently highlighted here, it's hard to see the key, but you'll see the number 199. This number 199 is the amount that Will had attempted to bond. We subtract $1, or I'm sorry, 1 token for validator joining fees. The RChain platform will require bonding fees. I think we did this to kind of to obfuscate the IP addresses. The RChain platform will require bonding fees as a result. So when you attempt to bond on the RChain platform, you're going to see that there's some amount that's deducted from the bond amount. That's what's currently implemented. It's not clear as to yet. We've not specified if the joining fee will need to be specified separately as part of the bonding request or in alignment with it. But if you want to observe whether or not you're bonded, the way to do that is you identify the block that contains your bond request, and then you do a show block on that particular block, and then the list of bonded validators will appear in every single block, and then you grep or look for your public key. And then if your public key appears in that block on your node has the updated state and believes you're a bonded, and then you can start doing block proposals. That's my demo. I'd like to turn it over to Mike Stay. He's going to do a brief demo on the name registry.
Thanks, Meta. Okay, so I've got the command line interface running here. It's very similar to the REPL on our node. Up until now, many of our contracts and the tutorials have used what we call forgeable names. That is, quoting a process that you can just write down in order to host the contracts we need or interact with them. So we would say something like contract at quote my wallet, say. This string, my wallet, is forgeable because I could just type it right there, and it is something that the language accepts. So once I do that, then I can invoke the my wallet contract saying my wallet. Oops. Thing nil. And so then it evaluates it and has some cost to evaluate it here. The problem with doing things this way is I can use the string my wallet, but so can anybody else, right? If I put my wallet up there and it has a deposit method, there's nothing to prevent someone else from coming along and deploying 1,000 other contracts at that same address. And so there's only a 1 in 1,000 chance, or 1 in 1,001, that I get paid. Instead, it'll go to one of their wallets living at this forgeable name. So in order to make contracts secure on the blockchain, we need two things. One is a way of making them public, and one is a way of preventing anyone else with a reference to that from intercepting the messages. So there are two parts to this that we use. The first is called the registry. If you've been paying attention to recent changes in the code, you'll know that we can now inject some built-in names by using this paren notation. So if I say row colon IO standard out, it used to be that we would send on at quote standard out. Now we use a different notation. We say new, we give it a name, but then we say, I want this name to refer to this thing. And so we inject the name, we look it up in a built-in map. We inject the standard out process. And so then when I send on O, it will go to standard out. But there's no way for anyone else to intercept now messages that I want to send to standard out. So when I run it, it prints hello world there. Something similar happens for the registry. We say new R, and then I'll say row colon registry colon insert arbitrary in, and then I'll have, oh yes, and I also want my contract in some stuff here. If I said new my contract in, and then these braces here, the variable my contract would be bound to a name that is only accessible within these braces. If I did a deployment that only had this new in it, nobody else would be able to call my contract because their code is not running inside these braces. So the registry is what we use to make something accessible outside of braces. So I'm going to add the standard out here. And then say contract by contract message equals send So now it's going to print a tuple here that has hello and whatever message gets sent to it. And in par with that, I'm going to register my contract in this. So I do rbang, then I pass the contract itself. And a channel on which to receive the URN. And I'm just going to print that URN. Okay, so we see up here at the top, it printed out this thing. This URN is how anybody can access my contract in the future. So then in their contract, they can say new lookup, row colon registry colon lookup. And I'll also use the standard out. We'll do lookup. We'll need a return channel. Lookup, bang. Then we copy this ID here and send contract as the return channel. In par with that, we say for my contract from contract, my contract bang world. Okay, so again, what this does is inject the ability to look up a name. I guess I didn't need this one after all. This is a return channel. So then I look up the unique identifier. It will get sent on this contract name. Oops. Sorry, I need a star there. So it'll get my contract out of the registry and then send world to it. Let's see. 156. Sorry, this interface is a little hard to work with. It was on 55. Oh, of course, contract is a keyword. I can't use that. I'll say return channel here. There we go. Great. So it looked up this, got the contract back, X3, and then invoked the contract with world. And so then it printed out hello world. So using the registry, we can expose contracts in a way that is secure. The one part of this that I didn't demonstrate yet is the notion of a bundle. So, oops, up here, when I registered it, I registered the name of the contract directly. So here I just said my contract. What we really want to do is say bundle plus of my contract. And the plus here says make this make this write only. So now when somebody looks it up and doing what I just did, they can get this thing and listen on it. But if I had the bundle plus in there, they wouldn't be able to listen on my contract. They'd only be able to send on it. So these two lines show how to create a contract, install it in a secure way using bundle plus, then look it up and invoke it. And these IDs are very similar to, say, Ethereum contract addresses in that sense. Right, any questions?
Mike, if you call that, can you just call and get the code of that contract as well and not interact with it?
No, what you get from it is a name. It is on a name that you communicate with the contract. What you can do is look up, once you have the name, you can ask the blockchain to find the block in which that name was first used, and then you can find the code. But you don't really want the code in the general case. You don't want to create your own instance of the contract. You want to use the existing contract and all of its state.
Yeah, but you might not necessarily know all the functions.
Sure, yes. You need to look at the code to know how to interact with it. And that you can do by asking for the block containing this name. Any other questions? Great, back to you, Meta.
Thank you for that, Mike. Thank you very much.
That is
wraps
awesome, guys.
Yeah, that wraps up my update. Node 7 is quite a large release. We have a lot of meat in it. Those of you that are interested in looking at the Node 7 release plan, feel free to do so. It is on the wiki, like all of our other release plans. I can share it with you here. And I will be drafting the release announcement for this week, so we can go ahead and push it out to the wire on Monday. Now, again, updating testnet is contingent upon us fixing 9.17. I intend on doing some preliminary testing this afternoon internally, and then hopefully a public test tomorrow to help suss out what the root cause of that issue is so we can fix it. So there probably will be a patch to Node 7 before we patch testnet. So please do stay tuned on that. Thank you. And that concludes my update. If there's questions, I'll take them now.
So yes, Meta, first of all, thank you so much. Great update. I wasn't aware that you're going to do demos today, but I was pleasantly surprised. Thank you very much. I wanted to ask a couple of quick questions. So the threading fix that improves the data access, does that also improve other performance aspects?
The threading fix is an initial fix in terms of the threading model in the node, and the reason it improves the data access is because of it affected the gRPC API, that endpoint, which is where obviously you get data from. The other components, the RSpace and Casper pieces, still need to implement or be folded into that threading model. That is the work that's continuing on. So when I hinted to that there is additional threading improvements to be made, that's what that was. So we've got an initial improvement, but there's more to come.
Understood. So in particular, I think one of the things that you and I discussed, and I was curious to see if there's any follow-up on that, is the allocation of the Roland constructs to threads. So in particular, if one allocates each for comprehension and or output to its own thread, then you get a significant performance improvement as you spin out more and more threads. But of course, that allocation has to be done by something. And it can either be done by the compiler or it can be done at runtime, in which case you have a scheduler in the way, and that scheduler can become a bottleneck for any performance improvements. And I'm wondering, sort of, have we sort of gotten to the bottom of that particular piece of the puzzle?
As far as I understand, the pull request to look for Sebastian's pull request in GitHub, as I understand it, there's a thread scheduler for the node, and I think that piece would come with implementing the threading in the tuple space is where I think that would happen.
Okay.
I believe
We're also chopping up what was a single big thread pool into lots of smaller thread pools, each with their own schedulers, so they don't interfere with each other.
That's a good halfway house. It's a good improvement. Very good. Awesome.
Yep.
Just wanted to check on that. And then the other piece of the puzzle. So that's on the plus side. Now, if we have a namespace, if we have a name registry indirection for all communications inside a contract, and in particular for all external communications inside a contract, what does that do to performance?
It's a great question. It's not something we tested yet. I think Kyle probably has some opinions and some ideas on that. Mike, do you have anything? You talked to Kyle about this?
Sorry, I missed the thing, something about internal and external.
Well, Greg's question is that there's dependencies in terms of looking up names on the name registry. What is that going to do to performance? Because everything will be going through it.
Right. So that's one of the reasons that we need peak is when you send to the lookup channel in the registry, we know that that's not going to cause any change to the tuple space, but without some kind of extra support, the Casper algorithm doesn't know that. And so by introducing peak, we can implement the lookup aspect in terms of it, and then know that all of those blocks doing lookups are mergeable.
Yeah, but that's not quite what I was talking about. Because what I'm saying is that effectively all significant communications are now going through an indirection, right? Because every single every communication has to go through the name registry. So now
you only need to do the lookup once, and then you can cache the result, store it in your state.
Okay, good. That's what I was hoping for.
Yeah.
I was hoping you were going to give me a caching answer. Awesome.
Yeah. Now, one thing I didn't demonstrate was the public key registry. I didn't have time to get all the crypto put together, but you, instead of registering something and getting back a random ID, you can register something at a public key and update that by incrementing a nonce. So there are additional ways to make things public. We're also working on a package API where it'll be where you'll be able to publish major, minor, and patch versions of contracts.
So can I ask a question on that, Mike?
Yep.
And it's kind of a question, but also it's to illuminate a huge power of RChain over something like Ethereum. If I have a contract and I deploy it at nonce 1, and then we improve our contract and we redeploy now at nonce 2, all lookups will be returning the new contract that we deployed, correct?
No, the lookups are the lookups allow you to specify major, minor, and patch.
Oh, even better. Okay, cool. That's really awesome. That makes the story of contract versioning so much better on RChain.
Yes. And there are arguments going both ways as to whether you want to allow a query like, give me the latest minor version of this major version. Do you always want to trust this other contract to do the right thing or not, right? And it really depends on the context of what you're setting up. We haven't decided whether we're going to allow that or not. If we don't allow it, then somebody else will write a contract that just tracks them and does it for us. So we might as well put it in. But if we put it in, then it's encouraging that behavior. So we're still discussing that aspect of it. But yeah, you'll be able to look things up by major, minor, and patch versions.
One other piece of the puzzle, Meta, you and I have been talking a little bit about the data access issue in terms of the long-term design of the data access strategy and or feature set. And one of the things I want to continue to point out, both to the community, but also in terms of our own design deliberations internally, is that Rolang represents one of the most sophisticated query languages you could imagine. It's an incredibly powerful query language, and so the data access story that utilizes an FFI as a built-in capability becomes very, very, very attractive for a wide range of applications. So in particular, if we end up with lots of data stored in the node, getting at it via an external interface is rapidly going to run into issues with respect to how to query that data. Whereas Rolang provides the most natural query model because the data effectively got in all cases via Rolang. And so, it would be natural to go and query for that data and then marshal it over via an FFI, as opposed to just having the gRPC capability. So I'm wondering, in terms of how we're thinking about things, it feels like that's going to end up in a Venus timeframe rather than in a Mercury timeframe. Is that correct?
Is that question meant for me or for Mike?
Well, I'm happy to hear from either of you.
I mean, I would say that for this project, I would not want to add any additional scope in as much as we can. So that's my bias there.
Yeah, agreed. Mike, your thoughts?
I'm sorry, I was doing something else. Is there a short version of the question?
Yeah, the short version of the question has to do with data access.
Okay.
Rolang is the best query language for querying the tuple space. It's way better than using gRPC as an access point for certain kinds of applications. So one way.
Oh, well, gRPC just encodes the Rolang, right? You
Yes.
encode it into a protobuf and send it over.
Understood, but when we're talking about query, it ends up being a different story. So you can imagine a different API that is FFI based. So you run some Rolang, you get a bunch of results back from the tuple space.
Oh, that's client API number 3. It's on plan as a patch to Mercury.
Awesome. Okay, there we go. Fantastic.
Yeah, and in fact, in that one, you're able to use unforgeable names as part of your query because there's no security risk because it never takes effect on the
chain. Yeah.
On the chain. Yeah.
Very good. Brilliant. That's what I wanted to hear. Fantastic. Good. Well, that's all of my questions. Anybody else have any other questions? Very good. So moving right along, we have a few more updates. I want to just mention that at 1:30 we have the third and final town hall meeting for those people who would like updates on co-op status in order to get items of business into place before the deadline, which is midnight tonight. We've already had the 2 very successful town hall meetings, and if you haven't had a chance to attend either of those, this is your final chance to attend a town hall style meeting to get any updates which you might find relevant to crafting items of business. But now, yes.
Yeah, so I have a question that's relevant to that. Among our membership, certainly the state of the platform is the question that's on everybody's mind and the most interesting thing. The second most interesting thing is our financials. And I'd like to know whether Kate is authorized to share with us, to share with the membership, the assets and liabilities, the balance sheet that we have at the current time.
Absolutely. We are providing a financial summary to the membership, and that will be available shortly.
So shortly means when?
This week.
Okay, and is there any reason that we shouldn't have that in preparation for the town hall meeting today?
Well, we wanted to provide it right after the final town hall meeting. So
Okay, thanks.
Everybody gets access to it all at once.
Okay, that'll be great. Thanks.
Sure. No worries. Okay, so with that, let's turn it over to the portfolio companies. Reflective. I know you guys have so we want to give some time for proof. It looks like we're going to be running over a little bit today, so strap in, folks. But let me turn it over to the Reflective folks first.
Hi, everybody. In case I break up here, I've got Kevin on standby to jump in. But before I hand it over to Luigi, real quick, San Francisco Blockchain Week is happening now, and I wanted to give a big shout out to Josh if he's on this call. He held a Rolang boot camp. Unfortunately, I wasn't there to see it. Gosh, I've heard a ton about it, so I wanted to say thank you to him for delivering that. Greg, I know you're speaking down there tomorrow, I believe it is. So thanks for everybody that's come by for that one. I'd like to share some screens here, and I can't do it on my mobile, so I'm going to have Kevin do it. And Kevin, why don't you go ahead and walk everybody through? There's a few things that we want to stress on. We set it up last week about the ecosystem that's happened with just on our side, just the 23 companies that we have actually invested in, and all of these slides we'll put up on the Reflective Discord channel, so you can take a look at it. But a little bit better view here, you can see of the ecosystem and the companies that we're in the different categories. And what we've done from there is we've broken it into a few different categories, and that is to show dollar transactions, so meaning the amount of dollars that are going through the system, not revenue to us or to RChain, but that these companies are pushing through on projections, and then also the amount of transactions. So if we look at the ecosystem transaction volume, you can see in April, assuming mainnet launches, then we're at about $30 million in transaction dollar value that's going through, and 90 million transactions. If you fast forward just 6 months, you're at 70 million and about 275 million transactions, and these are all per month. One thing that we did to show what happens if we continue on the same pace that we're at, which let's just assume 23 companies a year, which I know we will do at least that, and let's assume that those companies start to build faster and bigger and drive more transactions. And this does not include anything that comes organically. If you look at what happens a year later, so 2020 in April, we're going to be doing $150 million in transactions each month and 500 million transactions. The really cool part is another year ahead, we're at 1.5 billion transactions and 500 million in those dollars per month. Again, that doesn't include what Pythia is doing, all of the different apps that are going to be built by the rest of the community. So what this is showing is the great value of the RChain ecosystem and what can happen when we start to talk about this to the outside world. I haven't seen a lot of other platforms talk like this and really show true value in what is happening. So I wanted to call that out. So before I hand it over to Luigi, are there any questions on what we've talked about here?
Oh, great. I am so delighted that you did this. This is fantastic. This is exactly what we need in order to provide the kind of evidence for validators that this is the platform to come to. This is so different than the way, I have to say, I'm sorry, I'm just going to be rude and say blockchain heretofore has been entirely navel gazing. right? All the transactions have been internal to the blockchain, right? And so this is very strange sense of what value is. Here we're talking about real value because it touches people's lives, and not just in terms of trading imaginary tokens. This is fantastic. But it also shows something that I've been trying to make clear from day one, which is that arts and entertainment is absolutely the place where we want to go first. So you're at 90 million transactions per month, sort of in the first few stages. In the first few months of our song, if we roll out the platform as planned, we're at hundreds of millions of transactions per month out of the gate, and it's very low risk transactions, right? So when we combine these two strategies, like even if it turns off that our song doesn't make it as a music service, which is quite likely, like, hundreds and hundreds of music services get launched and die. How many have we seen in the last decade? But if at the time that either picks up and takes off or peters out, if we have another a wave of portfolio companies coming along with another supply of transaction volume, this is the kind of robust, healthy network that we need to see. So this is absolutely fantastic. I love it. With that, let me give it back to you and Luigi.
If there's no more any other questions from the community on this? All right, Luigi, take it away.
Hey guys, this is Luigi. We're really excited to share some of our progress with you all. For those of you who don't know me, I am the co-founder of Proof. I have been at Governance Forum and the other two conferences, and I believe I've met many of you over time. But I just want to take a minute to explain and show just a little bit of Proof from a UI perspective, and then I'll hand it over to Paolo to do a demo of the back end. So can everybody see my screen?
Yep.
Okay. So this is just a UI prototype of Proof. Essentially what you have here is voting cards and analytics based on people voting on articles. And what Proof is a platform that aims to clean up the web. We all know about the societal failure with respect to the problem of misinformation online. And we've developed what we believe is a scalable yet inexpensive solution to the problem. And so the way it works, basic functionality is, you're reading through your newsfeed, you see something that you question, and you could drop a URL to Proof. And that Proof, that URL, you'll be able to tag certain categories with. Once you submit that URL, it'll come down here, and you can vote on that. Assuming you've passed the necessary checks to become a verified voter, you can vote on that. And what we ask is that people research the contents of the article and put up a monetary stake, whether or not they think an article is mostly true or false. That's our initial launch product. So you'll be able to select whether or not it's an opinion piece and select your wager. Once the voting is complete, we use a tallying algorithm that we've developed with a 5-person economic team that once certain conditions are met, the algorithm closes the vote based on the necessary conditions for a wise crowd. And once that's complete, you'll be able to see here the analytics on the vote. How many people voted, what the median wager is, average wager, and there'll be more and more analytics over time. But what we're really trying to get to is a place where you can come online and see analytics on sources and topics. So if you want to read about a certain topic, you can see who are the most verified authors in that topic or the least verified authors with that topic. And with that, I'm going to pass it over to Paolo. So this way, everybody can get a sense of how we plan on interacting with RChain a little bit.
Okay. Hello, everyone. This is Paolo, and I'm CTO at Proof. And well, after all of these credible updates for RChain, it's going to be difficult to compete with that, but I'll try. We would like to show some of the progress and a simplified version presentation of our current architecture, and then an example of how RChain would be used for voting in our platform. So, well, those are the main components that we have, all of those are containers, and we run off Docker. We move from DigitalOcean to AWS. We have our current backend based on the latest Python 3.7 using the Django framework, of course. We have found a few difficulties into development of so many components. Exactly, for example, the dependency hell was one of them, and we found this pants building tool from Twitter, for example, that solves in particular that. And also pushpin was a nice thing to find for Python for real-time communication, not only for pushing on the front end and UI, but also for sharing some notification between containers. And then we have this queue that is needed for having the salary workers that will be processing those longer background tasks that are going to be asynchronous. And those would be, for example, well, one of the difficulties that we have in our platform is about parsing the articles and finding duplicates or checking constantly if the content is changing, because that would change the meaning of the vote. So for doing that, we use salary, and that will come handy also for entering the transaction or deploy or propose on RChain or any blockchain. And one thing that I would like to underline here actually is that we had this cool idea of abstracting transactions and making them based on database first for prototyping, and then implementing on Ethereum, and now we're moving on blockchain by using the same abstraction. So that was a thing that helped a lot in the current process of development. And apart from Postgres, the other important thing I would like to talk about is the Python gRPC client. This was written by us by starting from an example that we found on RChain repo, and was very small one, and then we developed on top of it and created some wrappers, and it helped us a lot because we really need to sync a lot and send and receive stuff from RChain, and whoever is using Python for their purposes, they can use the same library because it's already publicly available on GitHub, and we are in the course of integrating that with Joshi into an RChain official repo. What else? Well, there is a lot of room for improvement, and we are still in an earlier stage from the development compared to RChain, but this is the base. And the other diagram that I would like to show before a quick demo is this one to explain how vote will work between having users, the proof platform, and the RChain network. So the first thing to say, there is two kinds of users. The first one is the submitter that basically is sending us URL of posts and articles that are found on the internet that the user wants to be validated. Is it mostly true or mostly false? And the other one, of course, is the voter that it's supposed to say if that is true or false by betting. And since he's putting money there, it will be KYC. Then when a submitter is sending a URL, apart from having our background checks for parsing and checking for duplicates, if that is not a duplicate, we store in the database and get some ID. And what we do is already pushing through the gRPC channel, deploying a contract, and this contract will hand the voting for that article for the whole duration. So after that, the voters can come, they could say mostly true, mostly false, and put some amount there they want to bet, and this goes through, and we call the contracts to cast the vote on the chain, and then we get a receipt back, which is the hash of the user, the vote, and the amount. And at the moment, so this is going to be stored in a map store in the contract. And also the database will keep the counting on the votes because of the algorithm that Luigi was talking about. So for every vote now, we are currently deploying propose. And this should be asynchronous and confirmed by pushpin by sending a notification. But for the sake of simplicity here in this demo, we're sending back the receipt before the propose is confirmed. And well, while counting the votes, the platform verifies with this algorithm that all conditions necessary to help the crowd be wise and met. And when we have those, we call from the backend the contract on RChain to tally the vote. After that, the vote is closed, no other vote is accepted. And the beautiful thing that we can already do is to share a public channel that has access only read mode by using the bundle to query the results. So not only our backend can get this data that are immutably stored on the chain, but also anyone else who can run a roll-on contract. Okay, one other thing that I would like to say is that we are to give access to voting only from our backend. We are planning on using the RChain registry that Mike just already showed. And so we didn't have a chance to completely test it. And also our gRPC is not fully updated because the 0.7 just came out and we are using still the older 0.6.4 part. We'll try to update soon, probably next week. So a little demo, I have online here two R nodes. And what I'll try to do is to show that I can have some real code here. So these are Python wrappers written inside these notebooks. And I can run those cells here. What you can see is that those wrappers are just wrappers for our API to call some endpoints. And for example, to authenticate, in this case, a user and get a token. So after I get a token, I'm a submitter that can vote. So what submitter that can submit a URL. So I have a URL here. What I'll do is to do this to create a new submission. And when I do that, what happens in the node is that this new voting is opened with the same ID. And this is deployed, and we can see here that also in the slave node it arrived. So now voters can vote. I'll get the latest article ID inside this variable. And the code that I will show now is going to be the equivalent of people that are clicking vote like Luigi showed on the UI. So let me create some placeholders. This one is needed because I will do some random votes based on this list. And also for the sake of the demo, we will tally only after a few votes. The maximum votes for now it's 5. So what I'll try to do is to actually do more than the users, just to make sure that we show also that it's not possible to vote when the vote is closed. So what is going to happen here is that I authenticate different users, become some random answer from the answers that we had before, and then vote. And while this is happening, I can see here that I'm receiving requests for voting like this. And the vote that I cast is hashed, and only the hash is sent to the blockchain. And so this is 3 users already voting, and you can see that the same receipt that we have here is the same. Let me show this. So this one is this one here. And this is also deploying on the slave in the current time. And when we will reach, hopefully soon, 5, the backend should automatically see that we reached the conditions for closing. Okay, so we're at 5. And what's going to happen is to tally the vote, meaning that we deploy a new block where we say, hey, here it is. We are tallying the vote. And so after that, there should be still a user that tries to vote, but will not be allowed. Okay, so wait, let me show here. So I don't know if I can show the results from here. Let's wait for this one to complete because it should say that, yes. So this one was not accepted because the voting is closed. Okay, and so we can show that we are able from our backend to deploy contracts, to vote, to close the vote. But now the nice thing to show, the final one would be that we are using here our gRPC directly. we have using, of course, some wrapper class just to simplify this demo. What I will do is just to create a contract that is using this exactly is the content of the contract. It's going to use our public channel. There will be one for each article. Sorry. This, of course, now is just the ID in the database of the demo, but for sure it's going to be like a hash or something. And we are also using a channel to get the results back. So what I'm going to do now is to use the gRPC to deploy and propose directly in the code here, and then use the streaming with this listen on function that we were able to build recently. So we're going to get some output from deploy and propose. This is the output of the deployment that this is already happening here on the chain. Okay, so the proposal also was successful. We created a block, and now the stream is available, and we can ask for the next block in the stream. This looks something like this in the output in Python, but as you can see, I can directly get in the code in Python the results. I also have like a for cycle, I can get the block and parse it like this. And those are the 5 receipts that were allowed, so we can also check that if I go here and grab from the log, this was the 4th user accepted as valid. And okay, this is the end of the demonstration. And what else can I add? It's been an incredible journey already to develop these things on RChain. And I'm really grateful that there was a lot of help that we received from Discord, and everybody is so nice and available. And that was really, something that gives us also positive energies. And we are willing to test the new economics things and the registry and the few things remaining that really would allow us to do those things. And I think that RChain is giving us the possibility to do things that we were not ever gonna do on Ethereum or other platforms like that. So I'll send it over to Luigi to sum it up.
Thank you, Paolo. Go ahead.
Luigi, okay, go ahead.
I was just going to wrap up and just say that, I appreciate our team working hard and kind of blazing this trail a little bit alongside you guys. But a few things that we did learn and just from our experiences thus far is that, obviously Paolo mentioned anybody can leverage the Python API. It's open source. So, if you're using Python on your back end, happy to help out people with that. I want to point out Joshi and some of his efforts and tutorials with Rolang. They helped us a lot get up to speed faster. And one thing we did notice is the R node resource consumption was pretty heavy and breaking some of our unit tests, but obviously that's going to get better over time. But in general, from a business perspective, some of the things that we're still analyzing on chain is how many transactions we plan on doing, depending on the cost of those transactions. So really happy to see some of this data on phlogiston come in. This way we can better understand from a business perspective costs and make better decisions on what we want to put on chain specifically. So that's it for us. Anybody have any questions?
Actually, from a process perspective, I want to adjust things a little bit. I have 1,000 questions. And I want to say I am just delighted. Thank you. But out of respect to Pythia, I'm hoping that we can allow them to do their updates since we're already 8 minutes.
Sure, of course.
And then those people who want to remain on the call, and in particular, if you guys can remain on the call after the Pythia update, I would love to ask a bunch of questions. Does that work?
Sure.
Fantastic. Okay, so with that, let me turn it over to the Pythia folks, and then we'll circle back. Do we not have any Pythia folks? Oh, all right. Well, I'm sorry that it worked out that way. Okay, so in that case, I would love to launch into a few questions.
Hey, Greg.
Yeah?
Sorry to interrupt, but before we get to that, so there's something that's come up a lot this week at SF Blockchain, and now that we have a lot of the community here, I think it would be great to get your input on this, which is transactions per second. There's been a lot of talk about what's a true transaction, and if it's a COM event or is it a transaction. And when we say 40,000 transactions, do you really mean COM events? And then I heard on the meeting, the town hall meeting the other day, you had stated that testnet was up to 1,000 transactions per second. And then there was a question about that, and then it was, did you really mean COM events? And then you said a COM event could actually contain multiple transactions. So I just want to make sure that we're all on the same page, especially when we're talking to folks and we're saying, we're at 1,000 transactions per second on testnet now, and that in the future we are going to hit 40,000 transactions per second. That's actually an accurate description of where we're going to be.
Yes, of course. So just to be super, super clear, we always mean COM events. And the reason we mean COM events is because that's what corresponds to what is traditionally known as a transaction in computer science. When we talk about transactions, we're talking about things that share some of the ACID properties, i.e. atomicity, consistency, isolation, and durability, right? That's what is meant by transactions in a computer science setting. And on the blockchain, those have very specific and definite meanings here. Now, sometimes people want to refer to transactions in terms of finance and financial transactions. Those are a lot squishier in terms of any sort of semantics. So we could talk about wallet engagements or wallet interactions or wallet transactions. I want to be clear, however, that COM events, I never said that COM events equal multiple transactions. What I said was,
we should look at that video then.
Yeah, please do. Please look at that video. What I did say was that COM events can have, they can be much larger. For example, a single COM event, a single communication can ask for an entire audio file. And that was the specific example I gave in that video. So a COM event can be much more coarse-grained than we might think in terms of financial transactions, right? So a financial transaction, for example, updates a single number. A COM event can communicate an entire data structure, as an example. So apples to apples here is a little bit more difficult, but we are very precise in what we mean, and we've been precise since 2016.
But the one thing I hear a lot is that it's 40,000 transactions per second on the scale of Visa. And so in my mind, Visa, I go and I pay with my credit card, that's a transaction. You pay with your credit card, that's a transaction. And that's what, to me, not the computer science world, but that's what the business world recognizes as a transaction.
Right. Yeah. And because the COM events can be relatively coarse-grained, they can be as coarse-grained as you design your code, you can be in alignment with that notion. So that then becomes how you design your smart contracts.
I think the confusion here is that a transaction is an interaction. It actually requires two COM events.
No, a COM event is an interaction. That's the whole point. A COM event is an interaction between an output and an input. It's not two. It doesn't require two COM events to do a notion of interaction. That's exactly what a COM event is. So I really appreciate all of this clarification, and we can have an in-depth discussion about this. But since we have the proof guys here, and I don't want to lose them, and we're already well over the hour, I would like to get back to asking them questions, and then we can have a nice long detailed discussion about transactions. But RChain has always been very clear in all of our literature from the very beginning that what we mean by transaction is a COM event.
But that does nothing for business people, and that's what I think we need to drill into. And so, yeah, let's take this offline. But I think as we're on the front lines trying to get businesses to build on our platform, we need to have language that they understand.
Yeah, and
so
again,
let's schedule that. Yeah, can we schedule that? Even this week.
I'd love to schedule that conversation, but I will absolutely take issue again and again and again with any statement that says that does nothing for business people. It's very clear to a business person that if you send an audio file and receive an audio file, that has a clear business meaning. So moving.
Can I chime in just really quick? This is Patrick.
Sure.
I just want to say that amongst all of the wonderful things that Josh is doing, addressing this notion and kind of clarifying that language around comm events and what that means for different segments is on the short list of to-dos, and most likely will result in an index on the website within the next month or probably month timeline that kind of can clarify those notions for people to reference.
Absolutely, that's great news. So now moving on to the proof demo. By the way, I have to say that in 2009, I was contemplating with several entrepreneurs the revitalization of journalism via a decentralized platform that had micropayments. And so to see this come to realization in front of my very eyes in a short period of 9 years is just fantastic. It's phenomenal. I am so happy to see this kind of thing. So, but I wanted to ask a couple of different questions that are related to your architecture. First of all, I'm really curious. This is an outlier probing kind of question. Could you ever see a day in which your SQL server might be replaced by a node?
That's a great question. I would say that I'm starting to believe that it's possible, probably, and
Wow.
I mean the fact that everything went so smooth for me in approaching to something that was new compared to Ethereum, where you actually had to learn so much. While in RChain felt very simple to use the main things that are there and that they just work. And also experience that session by session, everything was getting fixed, whatever was not working. It's really only this economic thing that has to be sorted out soon, because the technical part to me looks like it's just going the right direction.
Oh, fantastic! I'm so glad to hear that. The other thing I wanted to ask is in terms of, like, I know that you've made the Python gRPC client available. Is there some way that you could take you probably have some special sauce on the other side, on your side of the wire there. But I'm wondering, is there any way you could, in the same way that Kayvon has kind of packaged up our song as a Docker image, so you can deploy the whole thing once and people can see it and they can sort of look at the code. Is there some way to craft some kind of dumbed down version of what you've got so that people could have an end-to-end experience, that they could look at the code and see?
Yeah, sure. I could actually, the notebook is just Python code, and there is like little helpers that I brought to use requests to call our backend and then to wrap into a class the gRPC base code. So I'm really happy to provide that as a public repo as well. And people can also see the read-only mode notebook and try to use the same code. No problem.
Awesome. That is really, really fantastic. I'm so glad to hear that, because the more we have these kind of application templates, the faster other portfolio companies and other projects can get to market with an MVP. And that leads me to my final question, which is how many engineers were devoted to the RChain side?
2.
So there were 2 engineers working for what period of time?
Difficult to say because it was very spotted. So
yeah, so there were like fits and so I can help out there. So there were fits and starts in terms of learning, and then realizing we needed to write the Python gRPC component, and then once we wrote that we needed to get a little bit up to speed on the Roland component. So I would say like once
some updates also.
Yeah, yeah. Node seshing really helped a lot, I'd say, getting us up to speed and learning various aspects. But I'd say once we were up to speed, we were able to put it all together in about I'd say a month. Right, Paolo? Is that fair? Keep me honest.
Yeah, sure. A month is fair.
So would a conservative estimate, if we even included the Python gRPC legwork, was 2.5 months?
Yeah, I would say that's conservative.
So 2.5 months with 2 engineers to get to this kind of proof point?
Yeah, that's correct.
Awesome.
Yeah, like there's a huge component of this application that's not being shown in this demo. The whole parsing of articles and the algorithm is what really takes a lot of time, but the RChain component has been quite nice from our experience.
Well, less problems.
Yeah, no, that's exactly what I wanted to focus on was in for all the portfolio companies and any other projects thinking about using RChain or deploying RChain in their applications. So we had a similar experience. We had 2.5 engineers for 6 weeks to get to the RSong proof point. And I believe that this is going to be relatively characteristic for projects that at least want to get as far as an MVP or some kind of proof point where they can demonstrate to a market, this is our vision, this is where we're headed, and this is why we think you want to invest in our token offering or some other kind of financing for the project.
Yep.
So fantastic. Did anyone else have any other questions?
If they were to replace their SQL database with their own shard, they would only have costs for things that they sent out to the globally, right?
Well, I think I understand what you're saying, Jim. Yeah, I mean, what they'd really have is an accounting, like if it's their own shard, right? Then they're now going to have an accounting system for their storage, and that could then feed into accounting for, like, right now, what they'd have to do, and correct me if I'm wrong, you guys, but you're going to have to figure out operationally what storage costs to you, and then pass that on to users of the system or
Exactly.
Yeah,
that's exactly right. And the other thing is we're still really, really keen to learn about unforgeable names, just because one component of our vote is that we really want it to be closed during the vote and exposed afterwards, and proving that we said that the votes that we received are the votes that we received, so we don't have any of the problems that Web 2.0 companies have where you need to trust us. So that's one component that we plan on doing a lot of research on. I'm happy that was just released as well. So the unforgeable name component.
Fantastic. So what that would mean, Jim, as I've understood the answer, is that with a shard-based storage mechanism, they can provide external evidence for why to clients and other users of the system why they're charging for the storage in the way that they're charging. So it provides a better accounting mechanism. And by the way, again, to the point that I made at the top of this community call, right now I don't think that many people are apprised of the environmental consequences of storing millions and millions of cat memes. And I think the more we can make the community aware of the costs of using compute infrastructure, the more the community can make informed choices about what exactly we want to pay to store, and maybe things that we might want to let go. And on that note, maybe we should let the community go and let everyone get the rest of their Wednesday to work on other stuff.
I have one more question, if I may.
Please go.
Thanks for the demo. I have a question regarding the incentivization. It's, from my perspective, it looks like a little bit like a binary created registry. Do you have any kind of bonding curves, and do you use any kind of identity system in the background? If so, which kind?
So from that perspective, it's very different from a curated registry in the sense that there is no challenge function, or there is no need for the actual identified user to submit the content. It can be submitted by anybody. So in essence, the author doesn't have to submit the article. Anybody can submit the article about the author. The other thing is that, like I said, not anybody can just challenge it. There's a vote that it happens. There isn't a simple time constraint that when it closes. It's more that the algorithm determines when the vote closes based on certain conditions that need to be met. Those are could be a variety of things such as volatility, number of voters, etc. With respect to identity, identity is is required for voters, so they need to pass a verification check. This way, we solve for civil attacks. And I think I answered the question. The incentivization with respect to how we do it, there is a payout at the end of the vote, and it's not just a simple majority versus simple minority. There's a quadratic function to that. So I don't know if any of you read the literature on quadratic voting, but that's something that we employ with our voting system to reduce the effect of whales. Does that help?
Yeah, that does help a lot.
Okay.
Thanks.
Yeah, and you can reach me on Discord if you have any other questions. It's at Luigi Domeno. So happy to chat with anybody about it.
Thanks to all. Another exciting RChain community hangout. We'll be back at this channel in an hour for a town hall meeting for those people who haven't had a chance to participate in the others. Remember that tonight at midnight is the time deadline to get any items of business in front of the board for consideration for the ballot. Thanks to all. Talk to you soon.
Bye.
Ciao, ciao.
Thank you.
Ciao.